part two of lesson 4, and this is the most difficult two-dimensional collision to solve because both balls are moving at the beginning of the collision. So we got to figure out the total horizontal and the total vertical before the collision. And then that's going to equal the total horizontal and the total vertical after the collision. So it's not really intensely more difficult. It's just more labor intensive. What we're going to have to do here is the red ball, we're going to have to separate it into a y component going down, obviously, and an x component going to the right. The blue ball, we're going to separate into a y component going up and an x component also going to the right. And then we're going to add those. Let's call this x2 and x1, and we'll call this y2 and y1. We're going to add those to find the total horizontal components and the total vertical components before, and then we're going to apply our conservation of momentum to after. All right, and yeah, I said from this point on, it's really just tedious. Now, one thing to note, though, however, is here's our diagram. The diagram is a sketch, and it may or may not be true. In this example, we've got a 1.2 kilogram red ball going at this velocity. We've got one that's almost twice as massive, twice more massive, going at a faster velocity. So the momentum of this blue ball is significantly greater than this red ball. Therefore, this red ball goes off here, and this blue ball goes down here. Well, that may not be the case. And so don't assume that the blue ball is going to go down in this direction. Since it has a lot more mass and more velocity, it might be at a really shallow angle. It might even be up that way. Who knows? So don't assume that the blue ball is going to go down, and then freak out if you don't get a positive answer in terms of your y component. Okay, now I'm going to go through this relatively quickly because we're just going to separate this into components. The red ball, we're going to separate the blue ball into components. We're going to add them together. So let's go with momentum before. The momentum before, and first we're going to deal with the red ball. So we're doing red, and the red ball has a y component going down, an x component going this direction. This is 30 degrees. Right? X, y, the momentum, and remember, in these problems you must be consistent in what your hypotenuse is, and it's going to be momentum. So momentum is mass times the velocity. The mass is 1.2. The velocity is 10. So in other words, this hypotenuse is 12 kilograms meters per second. We can then use sine and cosine and separate that into an x and y component. And again, I'm not going to go through the details. If you need to review the details of that, then go to the first lesson where I discuss how to get the x and the y components using regular trigonometry. And it turns out that the x component is 10.39 to the right, so we'll just call it positive. The y component is 6, and because it's going down, we're going to assign a negative to it, right? Or you can just say down, however you want to do that. Now we're going to go to the blue ball. The blue ball is going this way and this way. This is a 40-degree angle, so it has an x component going to the right and a y component going up. X and y, its momentum is 2.3 times, what was it going? 2.31 times 15, so it's got a momentum of 34.65, significantly greater, almost 3 times greater than the red ball. So keep that in the back of your head. We separate that into components using sine and cosine. Turns out the x component is going to be 26.52 to the right, so we'll say it's positive. And the y component is going up. That turns out to be 22.27. All right, so we figured out the x and the y components of the red ball. the x and y components of the blue ball, both before the collision. Now we're going to write out what the total x before the collision and the total y before the collision. And you can see your total x's, they're both positive. So you're just going to add those two numbers together, and you're going to get a total x of 36.93. I'm going to leave out the units, just we know we're talking about momentum. It's kilograms, meters per second. Your total y, and be careful here because one's negative and one's positive, so 22.27 plus negative 6, and that turns out to be 16.27. So those are our x and y components before the collision. After the collision, we also need to have x and y components that match those values. All right, so let's go to P after. P after. And the information that we're given is we're given the velocity of the red ball. So after the collision, the red ball is going in this direction at a 25-degree angle, according to the diagram. And it is going at a velocity of, I didn't see that, velocity of 13.5. So similar to the, or exactly the same as the previous question. 1.2 times 13.5 ends up being 16.2. So the hypotenuse of this triangle is 16.2. We have an x component, we have a y component. And let's do this exactly as we did the previous one. We'll calculate the x and the y components using trigonometry. Turns out the x is going to be positive because it's to the right, up 14.68. The y is also positive because it's going up, and it's 6.846. And note, when you're doing these problems in terms of significant digits, save it to the very end. Especially when you're dealing with numbers such as these, you'd want to go to at least 2, if not 3 decimal places with all your calculations, and then at the end, give your answer in the correct number of significant digits. Okay, so there's the after. Those are the values for the red ball. Now we want to calculate the blue ball. And according to your diagram, it's we're not actually going to, I'm not even going to do the diagram, because if you do the diagram for your blue ball, if I go like this, or the blue ball is going this way, it's going to lead me to some heartache and confusion. Maybe not the heartache, but the confusion. So let's not even do a diagram. Let's figure out what those components are and then do the diagram. Okay, we know that the total before of the x component before the collision was 36.39. The red one after the collision has accounted for 14.86 of that. So the blue ball afterwards, so the h horizontal components of the blue ball after the collision must be 36.39 minus the 14.68, which gives us 22.25, and it's positive, so yep, obviously going in that direction. Good, 22.25. The vertical, I could put x, I should probably just put x and y, but it doesn't make a difference. You get the idea of the blue. Now here's the one that's kind of surprising. So the vertical components of the blue, we started off with the total vertical components of 16.27. The the red has accounted for 6.846. So the blue is just going to be the 16.27 minus the 6.846, and it gives us a positive number, which should be somewhat of a surprise to you, maybe, maybe not. In other words, the blue ball is actually going up too. It has a positive value. So there's your 9.424, right? And there's your hypotenuse that we're going to solve for. Resultant, I put R for resultant, so you can put whatever you want. Put HYP or write a hypotenuse. The resultant vector, we're going to use Pythagorean theorem. The resultant angle, inverse tangent, and then you're going to get the momentum of the blue ball, from at which point you're going to calculate the velocity of the blue ball. So R equals the square root of 9.42 squared plus 22.25 squared. You end up getting an R value, and remember, this is a unit of momentum. I'm actually going to put the units in here so I don't get confused. And then you're going to use inverse tangent of, make sure you get these in the right order. And if you don't, you'll end up with an unusual answer, or a very big answer. 9 point, it's the opposite. Inverse tangent is opposite divided by the adjacent. So divided by the 22.5. And you end up getting an angle of 23 degrees. Okay, now remember, that's not the answer to the question, because the question was asking for the velocity of the blue ball, and therefore our final step is going to be to calculate the velocity, which is momentum over mass, which is going to be your 24.2 divided by 2.21, and you end up getting an answer of 10.5 meters per second. Now, how many significant figures are we dealing with here? 3, 3, 3, 3, 3, 3. They're all 3, so we're going to put our answer in 3 significant digits. The answer to this question, therefore, is going to be 10.5 meters per second, and the angle is going to be 23 degrees. And again, you got to be careful here. It's actually above the horizontal, not below. Not below, as the diagram seemed to imply at the beginning. So it's above the horizontal. Shouldn't be too surprising, because again, the momentum of the blue ball before the collision was significantly greater than the momentum of the red ball. Let's just look at that once more. The momentum of the red ball before the collision was right here. Whoops. 12 kilograms per meter per second. The momentum of the blue ball was almost 3 times that. It was 34.65 right here. So it's not surprising the blue ball actually does have a little bit of upward trajectory. Okay, so that is an advanced 2-dimensional momentum, conservation of momentum collision question. Okay, and if you can do one of those, I think you're set for anything mathematically in this course. It doesn't get any more intense than that. It's different, but it doesn't get any more intense than that. Hope you enjoyed it, and you have some fond memories of vectors from Physics 20. We'll see you for the last lesson, lesson 5.